Maybe we can get into that a little bit more in a minute. I wanted to kind of continue on the nutrition part with protein distribution. So you've done a lot of research in this area as well. And I had done some reading preparing for this podcast on like some of the nutritional surveys that are done in the United States. They're called NHANES, in terms of like how are people typically distributing their protein amongst their meals. And I think probably it's very similar to what's found in Europe, where people are eating the majority of their protein is skewed towards their evening meal, their last meal of the day. And in most cases, at least with respect to this NHANES data, it's about 3 times the amount of protein in their evening meal versus their morning meal or even their afternoon meal. Yeah. Does it matter with respect to how the muscle responds to amino acids throughout the day? Like, is it better to evenly have your protein evenly distributed, or can you skew it in the evening and still have the same? I don't want to just say increases in muscle protein synthesis, because as you mentioned, that doesn't always translate to gains in muscle mass. People are more interested in gains in muscle mass. So let's leave it with that endpoint.
So we try to make it more simple, but it is actually much more complex. But if you consider that a single meal containing 20 grams of a high-quality protein maximizes muscle protein synthesis for up to 4 to 6 hours, then it makes the most sense that every main meal throughout the day is an anabolic stimulus, so that you would have 20 to 25 grams of protein in your breakfast, 20 to 25 grams of protein in your lunch, and 20 to 25 grams of protein in your dinner. And then, theoretically, you have 3 anabolic stimuli throughout the day, helping you to optimize muscle building, not necessarily muscle building, muscle reconditioning. I actually make that mistake all the time by saying that it's not about muscle building, it's optimizing muscle conditioning. And that could be for the endurance athlete, that would be better muscle to do endurance type exercise, and for the bodybuilder, that might be a bigger muscle. That's what now everybody's being advised. For athletes that consume more than those 75 grams of protein, that you can also add another meal moment. And that's, for example, the pre-sleep evening snack. For example, if you exercise in the evening, you take a protein-rich snack after that exercise session in the evening. And when you had dinner, for example, at 4 or 5 or 6, and you have a training session between 7 and 9, you have a protein-rich snack at 9 before you go to bed at, say, 11. And so that's what a lot of athletes do, just have a nice distribution throughout the day. The long-term studies, semi-long-term on nitrogen balance or on muscle protein synthesis are not that clear. There's some studies saying you have better retention of your protein and of your nitrogen when you actually have a nice distribution. But we've also have a recent study that we show that if you have a huge meal, you have a greater anabolic response when you assess it over a more prolonged period of time. Now, a lot of people are now asking us, like, should I have one meal? No, it's a study to show that the 6-hour or the 4-hour response to a single meal can be longer if you give more protein, because all the protein still needs to be digested and absorbed. But that doesn't change what I think now, from all the evidence that we have, it's being advised to have a nice, even distribution of your protein in your main meals.
So let's talk a little bit about that study, since you brought it up, because it was surprising to many people. Maybe you can talk a little bit about the difference in terms of the quantity. It was like 100 grams of protein versus what has previously been shown, maybe 30, I think, grams of protein was something that's been shown in terms of maximizing. Now, this was muscle protein synthesis that you were looking at?
Yep. So the older studies, there's two dose response studies that show in healthy young people at rest or after exercise, 20 grams maximizes muscle protein synthesis for somewhere between 4 to 6 hours after the meal. So in that time period, 4 to 6 hour postprandial period, we call that. Some of that protein might not have been digested and absorbed if you give more than those 20 grams. So the 40 grams that they showed in those studies didn't show a greater response, but they only measured for 4 or 6 hours, depending. Now, we wanted to do a study to show that if you give 100 grams, which is absolutely not something that I'm suggesting that people should be consuming, that it takes longer to digest everything, and that you have a longer stimulation of muscle protein synthesis over a more prolonged period of time. So we also measured not over 6 hours, but over 12 and even 24 hours. And then we see that you get a greater response. Now, the interesting part of this study is we also assessed digestion and absorption. Now, that is difficult because how do you do this? Now, instead of infusing tracers only and measuring the incorporation in muscle, that's how you measure muscle protein synthesis, we actually did an experiment before that. We infused a cow with labeled amino acids. So you have amino acids with a chemical flag, stable isotope labeled. We infuse it in the cow. The cow actually incorporates it in the milk. So we have milk protein, and we extract the milk protein. So we have milk protein where those labeled amino acids are incorporated. And then we provide that protein so we can see the digestion. We see those labeled amino acids coming out of the protein being released to the circulation. Then we take a blood sample. We can actually see those amino acids. So we see how much of the protein that you ingest is released in the circulation. And then we can even see how much is converted to muscle. And then you see that it takes much longer to get all those amino acids in the circulation and also to get a longer stimulation of muscle protein synthesis. So simply regard also the fact that time is a factor in all of this. But of course, most of us eat one meal and then 4 to 6 hours later the second meal. And that's why all the previous studies always looked at 4 to 6 hour postprandial periods.
Unless it's your last meal of the evening.
Good point.
So the question then is, if it's your last meal in the evening, and let's say you've already distributed your protein intake fairly decently in your first 2 meals. Some people we'll talk about in a minute, time restricted eating and caloric restriction. But and let's say you want to go a little higher for your, maybe not all the way to 100 grams, but 60, whatever. Then would you, if you speculate on this, and there's 2 parts to this question, would you think that the increase in muscle protein synthesis would be higher if you had ingested 60 grams of protein in that last meal versus 25 throughout the evening, like we're talking like 12, 20 hours? And also, what if you then wake up in the morning and then you have again your first meal? Is that going to change the muscle protein synthesis, or are you better off having that meal higher? Are you going to are you really maximizing it?
I love those questions because the 3 questions that you now asked is probably 7 years of my life. So one of the things how I should start answering this is that we see a lot of people in the hospital losing muscle. And so they're admitted to hospital, losing a lot of muscle. And we know that the loss of muscle or muscle mass is an important predictor of clinical complications, readmission, health, etc. So we wanted to do something for patients to reduce muscle loss. So we thought, like, if we give these, just in line as with athletes, if we give these elderly people another meal in the evening, can we minimize muscle loss or stimulate muscle protein synthesis? Now, when you're in the hospital, it's probably here the same thing. You get your last meal about 5 or 6 o'clock in the evening, and then the next meal is breakfast the next day at 9 o'clock. So you spend more than 15, 16, 17 hours in an overnight fasted state, which is maybe nice for people trying to lose weight or anything like that, but for people at risk of muscle loss, it's not a good thing. So we started thinking about, if you give protein in the evening, is it digested while you sleep? Does this all work while you sleep? Now, that's difficult because you can't take muscle biopsies when somebody sleeps and not wake the person up. And you also can't ingest protein while you're sleeping. So what we did is, and that's when we started doing studies with the older people, the great volunteers, much better than most of the athletes, that they call us and then they actually say, like, Luc, I was in your lab last year. Can I come back? Do you have a new study running? And then I would say something like, oh yeah, you can come over. What we'll do, we'll put a nasogastric tube down your nose, in your gut. We'll take a muscle biopsy. Then we put you to bed in the hospital. Then at 2 o'clock at night, while you're sleeping, we'll tiptoe into your next to your bed, put 40 grams of protein in your gut, and then wake you up in the morning at 7 o'clock with a muscle biopsy. And then they respond like, where can I sign up and when can I come over? So these are cool studies. But they showed that if you give 40 grams of protein in the evening, that protein is digested and absorbed while you sleep. because we use that intrinsically labeled protein so we could follow it. And it's actually converted to muscle. Now, that study was weird because when we published that was a nice proof of principle study. I got a lot of coaches and people calling me, asking me where they could buy those nasogastric tubes. And I said, no, this is a proof of principle study. Just have a protein-rich snack in the evening. So just to make that clear, we actually followed that up with an athlete study where we showed that having a protein-rich snack in the evening is digested and absorbed and stimulates muscle protein synthesis overnight. And so that amount of protein will help you reconditioning more efficiently. That's the first answer to your, or the question to your first question. Now, the second was, is it of benefit on top of knowing that you'll have breakfast and lunch the next day? So we also did that study. We provided protein in the evening, or we didn't provide protein in the evening, and looked at the response to breakfast. Now, response to breakfast in both conditions was exactly the same. To my surprise, because I expected if you give a lot of protein the evening before, then the response to breakfast would be minimized. But it wasn't. It was exactly the same. So it does give me some insight that at least in the first 24 hours, you have a greater benefit when you provide sufficient protein to maximize the reconditioning.
What about people, so time-restricted eating, you mentioned a lot of people do practice time-restricted eating, and they're eating in an 8-hour window and they're fasting for 16 hours. And you've done some research in this area as well. So eating that large evening, that large protein bolus with your last meal, what if it's earlier and it's not like right before sleep, because you have your feeding window, your eating window, and then you have your fasting window. Do you think, based on your study with the 100 grams of protein, really extreme case, that protein will be digested longer and incorporated into muscle for muscle protein synthesis?
So based on the theory that you need an anabolic stimulus every main meal in order to get the optimal 24-hour response, then you would actually have to conclude that intermittent fasting of time-restricted feeding is not a good thing. But we've done a study, a more longer-term study. Imre Kouw did that with labeled water. And she did that when in Melbourne, where I had a visiting professorship position there. And we didn't see a difference in muscle protein synthesis with the time-restricted eating versus the non-time-restricted eating. So it's possible the explanation is that if you have a period where there's less or there's no food intake, but you had a greater meal as the last one, that actually also had a greater response over a more prolonged period of time, just like the 100-gram study. So it's possibly that evens it out. The other big question is, of course, why would you do time-restricted eating or intermittent fasting? The other thing on that study was we didn't see differences, or that project, I should say, is we didn't see a difference in fat loss. So, and I have a lot of people calling me and saying but the time-restricted eating, intermittent fasting really works for me. Now, I did it myself as well, and it works really well. Why? Because in the morning, I go to work, I don't think about food because I'm too busy and everybody's just walking into my office. By around 4 o'clock, I get a little bit peckish, so I start eating something. And then I get home around 6, and then around 7, I open up the computer to see what crap emails I got. And then I start having my main meal and snacking. If I decide to not eat after 6, I will eat much less than I actually require, so I'll lose weight. So basically, because more than 70% of my energy intake is after 7 o'clock at night, time-restricted eating would be great for me. But if I would eat all the food that I would eat after 7 throughout the day, I would not lose that fat mass and I would not lose weight. So it's a good way for people to cope with a lower energy intake.
Right. I think there's now been many, many studies that have found that people naturally doing time-restricted eating, in their free living conditions, on average reduce their calorie intake by about 200 calories per day. And that's just, natural, because people don't snack or they don't eat that dessert or they skip, because they are trying to restrict their meals into a shorter time period. But, and I think you've even shown this in other studies, many studies have shown, if you do keep calories the same, you will not lose fat-free mass and weight, right? then the glucose homeostasis is still improved by not eating in a huge, like by restricting your time eating window shorter to, let's say, 8 hours, in some cases 10, but mostly 8, even shorter than that, 6 hours. So there are people also that are very interested in their glucose homeostasis that, want to eat within a shorter time window as well. But the question then is, well, if they're skipping meals or skipping snacks, then they're potentially skipping protein intake, right? If someone is doing the time-restricted eating schedule where they're eating within an 8-hour window, then they really do need to make sure they're not losing their protein, correct?
Yes, and so if they maintain their normal protein intake, then they should be fine, because it's possible that more protein per meal has a greater effect, like the 100 grams. But the other part is also, it's funny, but we always end up talking about nutrition, and then we don't talk about the physical activity, because, the same thing when people ask me, like, what should I eat to lose weight? And I always say less, because there is no magic bullet. But the physical activity, we know from all hypercaloric diets, that if you actually are on a hypercaloric diet, that 2 sessions of resistance exercise throughout the week prevents the lean mass loss. So maybe instead of focusing on the protein, focus on physical activity in order to maintain your fat-free mass by doing 2 resistance exercise sessions a week. Much more important than the protein.
So let me rephrase my question. For someone who's doing time-restricted eating in an 8-hour window, fasting for 16 hours, and they're engaged in resistance training at least 3 times a week, minimum, and they're taking in their protein, they're not missing their protein.
And they're doing the resistance training.
And yes, can they gain muscle mass? Can they gain it?
Yes.
Yes. Okay.
That's an absolute yes. There's even studies that. 0.8 grams of protein, you can actually gain muscle on 0.8 grams of protein. Maybe you can gain more muscle on 1.2, but you can still gain muscle on a 0.8 grams protein per kilogram body mass per day. The body is much smarter than we think. If you actually do exercise and we ingest the same protein that we can track throughout the body, we see that the same amount of protein is, of course, digested and absorbed, but more goes to the leg that did exercise. So there's also an efficiency effect. Physical activity makes you more of what you just ate. So more of the protein is actually converted when you perform physical activity. So the body gets smarter how it handles protein.
I have a question. So if we were talking about protein distribution and perhaps, it being beneficial to more evenly distribute protein. But how does physical activity, because you said physical activity sensitizes, you said it sensitizes muscle to amino acids. How does that change whether, you would think that in the background of someone who's physically active, does all these other little differences matter?
I think so. All those little things that matter. To look at a cyclist, it's the bike, it's the helmet, it's the nutrition, it's the training, it's the mental coaching, and all of this together make the better athlete. So it's all these small things. But so what is interesting to see is that you have an anabolic response to feeding, you have an anabolic response to exercise, you have an anabolic response, a greater anabolic response when you compare the two. Now, the nice thing is that I think question number one, the question I was being asked the most is, do I need to take the protein before or after the exercise session? Which is almost the same question you're asking. Should I do the exercise before the meal or after the meal? It's basically also the same thing. It doesn't really matter that much because exercise makes the muscle more sensitive to the stimulation of muscle protein synthesis through food intake, but it does so for up to 24 to even 48 hours. So if you do an exercise session today, your response to breakfast tomorrow morning will be greater, but also lunch tomorrow afternoon and also dinner tomorrow night. And so after that, you have your second exercise session. So it's not about what should go first, but it's a consistency of training and meals in between. And the training will make your meals more efficient in how they optimize muscle reconditioning.
Well, the thing that's so interesting about this recent study that you published on the higher dose of protein and that being incorporated into muscle is, so if you have that 24-hour anabolic window, as you're saying, and you're going to be more sensitive to amino acids throughout that 24 hours, of course, then every meal, so if you have 10 meals on the extreme end. Okay, every 10 times, 10 times of protein, you're going to be sensitive to that protein because it's still within that 24-hour window. However, if you don't have time because you're working, as you said, to eat 3 or 4 or 5 meals throughout the day, it's also nice to know that you can go a little further than 30 grams in those, let's say, 3 meals, and perhaps still get a similar amount of muscle protein synthesis. In fact, let me ask you to speculate. Let's say a person did 2 people, or the same person, and you did a crossover study where they do both conditions. They're doing their resistance training. Their anabolic window is 24 hours. They're sensitive to the amino acids. The first time they're eating, let's say, 80 grams of protein. They're doing that within 5 meals, or they're going to do it within 3. Do you think they'll have the same amount of gains in muscle mass?
This is a cool study, but I think if there's differences, they will be too small to pick up. That's one. If you would have each of those meals would have 20 grams, so it's depending on total protein intake. If you do, for example, 5 times 20 or 2 times 50, does that make sense? Yeah. I don't think you'll find any difference there. If you would do, I would be less sure about my case, if you would do 20 times 5 grams versus 3 times 33.3.
Okay. So
that maybe there's a difference, that you don't reach that so-called leucine threshold. But to be honest, if there's the day before, there's physical activity, a good training session, with the legs involved, I'm not so sure whether we would be able to pick up a difference there.
Okay, so it's
pure theory, of course.
Yeah, speculation. Essentially, it sounds like, certainly in the context of training in the background, that you can skew your protein somewhat with your meals and still not be missing out on what you otherwise would gain in muscle mass.
Rather not worry about that, but don't miss that training session.
Absolutely, that's the essential thing. That's the baseline, right?
But,
you have to.
But the more
training.
people talk about nutrition, the less they're actually doing the training. That's what you often see.
I know, it's true. It's absolutely true.